go ahead and kick this off, guys. Hello, everybody. Thank you for joining us for another session of our WGI Lunch and Learn series. For anybody that's unfamiliar with who we are, WGI is a national design and professional services firm leading in technology-based solutions for the construction of public infrastructure and real estate development. With over 600 professionals spread across 18 offices, we're looking forward to working with you on your next project. Today's session is about developing a parking facilities restoration program. Our WGI experts today are Andrew Kong and Juan Sanchez. Andrew is a restoration manager in our Charlotte office who is experienced in structural evaluation and analysis of existing parking structures, life cycle analysis, design of various repair options, estimating repair costs, and construction administration. Juan Sanchez is a project engineer who is also from our Charlotte office. Juan specializes in structural restoration and preservation solutions, due diligence evaluations, structural strengthening and design and detailing of commercial buildings and parking structures. As we go through today's session, please don't hesitate to ask questions using the Q&A feature or the chat function in your Zoom browser. At the conclusion of the session, we'll prepare attendees attendance certificates for continuing education credits. Before we get started though, I'd like to invite you to connect with us on social media and join us for our next Lunch and Learn session, Placemaking During a Pandemic, taking place on March 17th, featuring Andrew Howard, Director of Placemaking at WGI. With that, I'll go ahead and hand it over to Andrew and Juan. Thank you.
All right, fantastic. Hey, thank you, Cole. Hopefully everybody can hear me. Good afternoon, and thanks for joining us. And we have both folks internally from WGI that's joining us and folks from the outside, a lot of professionals in the industry that we're in, others not so much. So we certainly appreciate you taking time from your lunch to join us. So today we wanted to talk about how we go about developing a parking restoration program. And with our Charlotte crew, you can see our team here. Juan and I will be taking you to the presentation. We have Attila and Mia. Even though she's not in Charlotte, she's an integral part of our Charlotte team and what we do. She's in the Texas office, and so we want to kind of give her a shout out. So as Cole indicated, we're going to allocate 10 to 15 minutes at the end, depends on how well the time goes for Q&A to answer questions you may have. So we just ask that you hold those questions until that point. All right, so today our goal is to really talk through a little bit through these items. We want to make this presentation short and sweet, not too complicated. Just to give you an overview of what we do in terms of parking restoration, different types of failure that we're trying to prevent, the different types of parking decks, and you can read the rest there. We'll talk through a little bit the common types of deterioration that exist in most parking structures when we get involved, what we do from that point in terms of developing a restoration program from construction through administration, and then we'll kind of share a couple case studies to kind of highlight what the process looks like, and then some before and after of different types of repair that we've been involved with. Those before and after may include projects outside of just parking structure. All right, so again, our main goal here is when we do a parking structure restoration program is to make sure the structure remains serviceable. So that's kind of our overall goal. We don't want the structures to get to a point where you're going to have major failure. So that's the whole idea of us getting involved and doing this. So the next few slides that Juan is going to talk through will highlight some failures in parking structures that we try to prevent in terms of when we develop our restoration programs.
All right, thank you, Andrew. So here we have an extreme example of a failure resulting from lack of maintenance. You can see in the upper left picture that the connections that were supporting the facade or the spandrel from the parking deck, they got corroded, they were compromised, they failed, and then the spandrel, which is on the bottom left, broke away and fell on top of the tractor trailer. We can also have failures resulting from overload in the structure. Again, here we have some extreme examples. The picture on the top left, you can see that the accumulated snow very high, and that led to the failure of the structure. And then on the picture on the bottom left, you can see a tanker truck that overloaded a parking structure. The picture on the top right, again, similar. The structure was being overloaded by a food delivery truck. Again, it's a parking structure. Failures can also occur due to fires. So basically, when concrete and steel receive high temperatures, the yield strength of the steel and the compressive strength of the concrete, they are reduced, and this is a process that is inelastic. So basically, the reduction in strength is permanent. Here we have some older failures, and again, these are extreme examples. These failures probably occurred due to a combination of lack of maintenance and inadequate design.
All right, just to continue on some of these extreme failures, and extreme doesn't mean that they likely won't happen. In this scenario, consider standing in a parking deck and the section of the floor, falls through right there where you are. Those are things that when we go and do these assessments, we're looking for. Yeah, another extreme case here is, I think it was 2 years ago in Texas, where this parking structure, you can see, I can't imagine you're sitting in your car and the floor of the garage falls out. I can't imagine. But, and what it tells us, is how much effort and the intensity when we get into the structure of thinking what we need to do to make sure that we can cover as much as we can to eliminate issues like this happening.
Yeah, so in general, we can classify parking structures in 3 categories. The first one on the left is a precast parking structure. So pieces are typically cast in a factory setting, and then they're put together in the field via welding some of the embedded connectors. It's basically like putting together a set of Legos, and in some cases, we install a field cast topping on the driving surfaces. The next category are steel parking structures. Beams and columns are made out of steel, but typically the driving surfaces are cast in place, and they could be conventionally reinforced, or they could have a combination of conventionally reinforced and PT cables. And then the last general category for a parking structure are cast in place parking structures. Some of the older structures are conventionally reinforced, and then the newer structures have a combination of conventionally reinforced and post-tension cables on the driving surface.
So the main reason why we've kind of highlighted the different types of parking structure, as Juan alluded to earlier, is because we want to kind of get to this point here to say, not all parking structures are equal, right? So, as they say, unfortunately, you get what you pay for. So in most cases, we have, as Juan alluded to, different types of, common types of parking structures that we deal with. And here we're kind of highlighting, some important aspect when you start thinking about designing and implementing new parking structure. You got to think about the quality of construction and the maintenance that's required. So in most cases, as you can see from the table here, the initial cost for like precast is much lower, but in terms of the maintenance is much higher. So there is a trade-off. Same thing is true in the conventional reinforced structure. The initial cost for the structure is much higher, but in terms of the maintenance is much lower, and in terms of life expectancy is much higher. So that's the key, and unfortunately, a lot of times we will get into a scenario where folks will build the lower end structure, but they don't accommodate enough monies in there for maintenance and understanding what the likely outcome can be if they run into deferred maintenance. So this table is just to kind of show you that you spend more upfront in order to spend a little bit less in terms of long-term maintenance of the structure. So why? How do these parking structure restoration programs are initiated? So there, what we've derived is usually from 3 different scenarios. A lot of times we'll get called for assisting clients with developing due diligence, whether they're selling or acquiring new properties, or just normal routine for a client that wants to do yearly or just typical engineering condition assessment of their structures. And then the other is scenarios where things fall apart in the garage and they have issues and they call us in to say, hey, we need help with these items. So typically that's kind of where we start a lot of times. If we develop these reports or we get called in that there is an issue in the garage, would they need assistance with developing a repair program. So the other part of the coin is who should be completing these review and inspection. And so here, in terms of a routine maintenance, that can be done in-house by, the client's in-house staff that understands what they're looking at, or contractors. But as it pertains to structural and waterproofing, life safety, that should be done by qualified individuals, a firm that has individuals that understand how these structures behave. With parking structure, you can't fix what you don't know how it's developed and how it's going to behave. And if you don't have training and experience in understanding how it was constructed in the first place, how it was designed and how it should behave, then it's hard to diagnose what are the issues and how you address that. So as far as that is concerned, you need individuals that are trained and experienced. And so when we put together a repair program from either of the initial scenarios that we talk about, it's typically laid out in 4 areas: items that are considered not compliant, code compliant items like ADA guardrails, and then most of the main items that we end up dealing with are structural repair items, whether it's concrete, slabs, beams, vehicular guardrails, stuff like that. Then waterproofing items, sealant, deck coating, expansion joints, plaza system, and then we have a category of, we kind of separate them as miscellaneous. And then these are not, it's not a complete list, but it's just kind of how we pocket the different types of items that we include into our repair program. So, the next step is, Juan will kind of take you to some of the typical deterioration that exists in us developing these programs.
Yeah, so parking structures are typically open or partially open, and therefore they're exposed to the weather. And, this exposure leads to a more rapid rate of deterioration. Some of these slides, some of these pictures are showing. And then that water, and sometimes it mixes with de-icing salts. It gets through cracks in the concrete, and that reaches the reinforcing steel. The reinforcing steel then expands, and then this expansive force spalls the surrounding concrete. Here are some good examples of, concrete spalling due to the reinforcing steel expanding and corroding. And then some other effects are due to inadequate design. Parking structures are very complex structures, and errors do occur during design or construction. Picture on the top left, the reinforcement was missed on the wall, and then the T that was supporting the driving surface above basically came down. The only thing that was supporting the driving surfaces was the door frame. The picture on the bottom left, this guardrail was inadequately designed. I'm actually going to talk about that project in a few more slides ahead. And then the picture in the middle is a PT beam that was under design. Again, was showing some signs of distress. And then the picture on the right, this is one is a little bit harder to see with the untrained eye, but basically it's a short column, it's very rigid. The driving surfaces, they want to move in different direction, and they can because the column is very rigid, and then you see all this distress cracks forming.
All right, so those are some of the common distress that people will see, and again, those are not all inclusive. We just kind of identify those because a lot of times those are most common that folks will see in their garage and understand that, hey, we have an issue. So with that being said, once we get pulled into kind of determine what's going on with these parking structures and identify the items that needs to be addressed by the client, or the, whoever the stakeholder is. They'll ask us to put together a program to address, certain items based on whatever their capital budgets are and depending on what are considered immediate or long-term. So before we even get started, once we get engaged, the first thing we do as a firm, we sit down and kind of go through, the foundations of what will make our project successful. And here kind of highlighted some of the requirements that drives a successful project from, these are key bulletin items, kind of maintaining communication, setting clear defined goals and objectives, setting our reaction time, and establishing periodic meetings, and how, figuring how we mitigate the different risks that may be involved in the project, because all these projects are unique and different. No restoration project are ever the same. They may have similar type of repair programs, but they're never the same. So as it pertains to putting together a set of construction documents, and our goal here is just to kind of give you a broad overview of really, it's a lot of information, but here we just kind of want to take you through the what we go through in terms of processing of starting from the assessment and how we put together these documents. So as far as the construction documents are concerned, for it to be effective, we believe that at least these 10 items need to be clearly adhered to. For one, you have to have clear set of drawings, because too often the contractor will call you and say, what do you mean here? What is this, information missing? So, having a clear set of drawings is very important. The scope needs to match the owner's budget, because sometimes, if you're not experienced enough or in doing what we do, you can develop a set of scope that's outside of the client's budget, and at the end there, making it pretty is not what we do. We have a sole objective to make sure the structure remains serviceable. So, we have to make sure we develop the right scope that's going to fit the client's budget. Understand the schedule. Set the schedule as part of the construction document, so the contractors know the duration that they have to complete certain activities, certain sections in the structure. Where possible, have liquidated damages if needed. If a project is very complicated, and there are many different drivers that will determine whether or not you need to include liquidated damages as part of your contract documents. And again, the goal of putting together liquidated damages is not to penalize the contractor, but it's more of an accountable portion of what we do. Specify the right products. Not all products are equal. We don't want certain material for certain applications, right? We have specific products that's specified for overhead repair, which is different from topside repair. Same thing with knowing whether you're going to use a sealer versus a traffic barrier membrane. Specify the right product for the right application. Understand the local ordinances. Know where you're working, what the code requires. Know what the county or the city or the jurisdiction require. Can you work at night? What's your noise limit? What's the light limits? Understanding the area that you're working in, because you're going to set those guidelines early. Establish clear goals for warranty. What products have what duration for warranty? Get sample warranties if you can, so the owner can see what the warranty is, because oftentimes you get the warranty at the end and says, well, what's this? This is not what we asked for. So if you can get those warranties up front and discuss, give it on to your owner so they know, this warranty has a transferable clause in it or not. Identify testing requires. What kind of testing are we required? Who's responsible for those testing? Special inspections, whether it's concrete testing. Identify those things clearly up front. Make sure your documents go through a quality control review process, on the internal side. And then at the end of the day, make sure you give a copy to your owner so they understand what's being developed and how it's going to be executed. And part of, just having good set of documents, as they say, the devil is in the detail. So make sure you have the right detail for the right application. Here we're just kind of showing a, partial depth slab repair detail. And on the right side, we're showing how that's executed, making sure things are square cut, that the right reinforcement is going back, the right depth is achieved, because you're trying to establish something for in terms of long term. And then we talk a little bit about phasing. In most parking structures, it's quite rare when you get a large amount of space, because a lot of these structures are revenue generating. So you have a limited number of space, whether it's 100 out of 1,000 space that you got to work with. So you have to have a way of telling the contractor how to move around to create a safe environment for them to do the work, and figure out what's the most efficient way versus their duration. So having good phasing plan is critical to the outcome of your project. And here again, as part of your document, you need to highlight what are the safety constraints. Safety is on the contractor, but you need to define what those minimum requirements at least needs to be. So here we have details for how they should set up their barricades. This structure here, we actually have a temporary lights that in the garage to help with traffic control as part of the barricade and signage. And so once you've established the construction documents, the next thing is find qualified contractors. That's the key. So in bidding, you need to make sure that you select the right contractor that understands or has the capability to do that kind of work. So on the private side, we have a lot of leverage in doing that. On the public side, not so much. But if you have a good set of documents, the same should apply. Give these contractors enough time, to put together a reasonable bid. So at the end of the day, you get a bid that's, you can really understand what's being asked or what's being provided. Where possible, have a pre-bid conference, make it mandatory, so you can explain what the expectations are and go over the drawing so everybody can see, here's what we're trying to do, here's what we're asking you to do. So there's, limited questions. And at the end of the day, once you get the bids back from the contractors, make sure you create a bid comparison spreadsheet to look at all the numbers, in line with each other, to see where there is any deviation, so you can go back and question whether or not a price is too low or too high, to get the mindset of what the contractor is thinking. Because sometimes people make mistakes. They may assume something that's not really the intent. And make sure the math works out, because sometimes folks are speeding up to get their bids in, and they may miss a number, and you don't want to penalize them for that. And it drives back to the lowest bidder is not always means that it's going to be the best. The overall bid needs to really showcase this is what it takes to really do this work. And based on our experience, it's easier for us to identify where there may be lapse and there may be change orders or issues further on going forward. And then at the end of the day, assess and make a recommendation to the client based on, your experience and what the bids say.
And the last piece of a restoration program is the construction administration. I think in my opinion, this is one of the more challenging pieces, because the facility is in service, you're dealing with old structures. Usually there's a lack of existing documents, and there's always unforeseen conditions. So for a successful construction administration process, your restoration consultant should always have a role in construction administration, should have a heavy role, and should be as involved as possible. Now, there are some limitations, because we need to be aware of the scope and the schedule. There's, depending on the complexity of the project, there will be a number of site visits. More complicated projects, we need more site visits. Easier projects, not so much. And then to accomplish this, we need to set the expectations early, have clear communication, and have a pre-construction meeting. Usually I like to set my expectations early by requesting contractors to do mock-ups of all the repair items. And then that way we can agree to an acceptable criteria. And then we should have complete periodic meetings, site visits, and field reporters. The periodic meetings are typically phone calls. I'm usually on the phone each week, speaking with a contractor, trying to get an update, trying to answer questions. And then the site visits are very important because we use them to quantify their repairs and to make sure that the repairs are being done in accordance with the contract documents. Field reports are a must. This gives an update to the client, and also we use that to track discrepancies. And then safety must remain a priority. Although safety is the responsibility of the contractor, we're usually there making sure that they're following OSHA guidelines. Here's a couple of images of our involvement during the construction administration process. And the picture on the left is during a concrete pour. You can see Andrew being there. So we like to be there during key activities. I was probably there the day before reviewing the reinforcement. The picture on the right, there's several levels of parking deck underneath. As you can see, we're there reviewing the prep work. They are installing a waterproofing system, and then this will turn into a plaza system for our hotel. Here are some more examples. The picture on the left, you can see Andrew, he's observing the installation of carbon fiber on the top surface for negative reinforcement strengthening. The picture on the middle is a pre-construction meeting. Basically, we have concrete supplier, the concrete pump, the engineer, the contractor. This is the day before the pour. And then the picture on the right, that's a 5 a.m. in the morning, the day of the pour. We're also there making sure that we can answer questions, checking elevation, dictating where tool joints go. You know, we do have there's usually a special inspector involved that works for the owner, but they have a different role. We're just there to kind of answer questions and make sure that things go according to our contract documents. And then now I'm going to do a small case study for one specific issue. So this is Harbor Review parking structure. This was constructed in the 1980s. It's a field top precast parking deck. It has 5 levels. We were tasked by the owner to kind of retrofit the vehicular and the pedestrian guardrails. There were some other miscellaneous items that we worked on. One of the major constraints was that the structure was in service during the repair process. So as I mentioned earlier, we were tasked to retrofit the existing guardrail system. You can see the existing system in these pictures. You know, initially the system looks very robust, you know, but looks can be deceiving. On the next picture, you know, point in case, the guardrail was tested. One of the patrons in the garage, she suffered a heart attack and she hit the accelerator instead of the brake, and she put the guardrail to test. As you can see, although the guardrail stopped the car from falling off the structure, it kind of did a poor job, and it did not act as it should have, as intended or as required. And then here I have a little free body diagram of the existing system. Basically, the issue that they had was that the low pad was incomplete, even though the steel members appeared to be robust. The area in red is basically, that was the weak link. You know, if you can go back to the previous slide, you can see the failure happened at the edge, and you can't see any type of reinforcement or anything that was tying the curve back to the double T's. It was almost like a clean cut. So going back to the free body diagram, you know, the load pad wasn't followed correctly to the double T's, and then from the double T's back to the beams and columns and foundation. So during the retrofit, and you know, this is, you know, one item, one simple detail, but you know, and there's different ways of addressing this. But during the retrofit, basically our goal was to complete the load pad. So we transfer through a series of plates and brackets. We transferred the loads from the barrier above to the double T's. And then some of the challenge is, for example, these double T's, they're cables. So you need a qualified firm or qualified individuals that can assist the contractor and tell them basically where there's no cables where you can drill. So you need a qualified firm that has expertise in precast structures, steel elements, and then carbon fiber repairs. If you look at this next slide, so basically the double T's were damaged during the accident. So we had to epoxy inject the cracks, and we have to strengthen the double T's with carbon fiber. The gray hatches that you see, that's the carbon fiber reinforcement. And then on the bottom, it's kind of hard to see. There's some carbon fiber plates that are also used to strengthen the double T's in flexure. And here's a after picture. You can see on the left, you can see the carbon fiber, the black elements, the wrap around the double T's. You can barely see any cracks on the double T's because we epoxy injected those. Then on the bottom, it's a little bit hard to see, but there's the carbon fiber plates to strengthen the T's for flexure. And then you see the new brackets that were put in. We have to check the double T's for punch and shear. This was a little bit of a challenge because there weren't any existing drawings, so we had to kind of rely on our experience to check the double T's. And then in the picture on the right, you can see the new pedestrian black railing and the new pedestrian, the new vehicular rail that we put in all the levels of the parking deck.
Okay, so that's the first case study, and the goal here is, again, to kind of highlight the complexity of parking structures, and for folks who design or repair and work in parking structure, we know parking structures can be very complicated. And so the thought that we came up with when we talked about the previous case study that Juan highlighted is, let's talk about a deck that's above grade. Let's talk about a deck that's a precast, and just the different elements. So Juan just kind of talked through a above grade precast parking structure. And so now we want to talk about a below grade, a subterranean parking structure that's below a hotel. So we're looking at here at this case study is the Embassy Suite parking deck. And you can see the structure was constructed in the 60s and conventionally reinforced. So we have 4 levels. So here you're in a large city, tight constrained spaces, and you have 4 levels of heavily deteriorated parking structure below 28 floors of hotel. And what this goes back to is, before we started talking about the construction documents, we really talked about the foundation of what makes our project successful. And these projects are the one that really drives that home. Is really, we have an active hotel with 28 floors above a structure that's heavily deteriorated. How are we going to make sure we implement a repair system that's going to create the least inconvenience to the folks who are occupying the hotel, and what's going to be the most structurally sound type of repair? So we just couldn't go in and just start demoing concrete willy-nilly. It just wouldn't work. We couldn't go and use jackhammers because the vibration of the noise would just be hell for the guests to pay. So we had to really think about, what approach are we going to take to address the repair items that we have there. And then again, the constraints were, we're below grade, everything is going down below grade, the streets are very tight, and we have an active hotel. So we had to be making sure that we're coordinating with the city, we're coordinating with the hotel manager, we're coordinating with the owners, and then the contractors and all the testing firms. So, it becomes, pretty complicated. And here we're just kind of looking at, some of the different types of distress. So this garage, again, deferred maintenance has put it in a position where, things were, actually, to a point where you're like, oh my goodness, it's hard to see myself parking in that garage. The floors, concrete, you can take up with your hands. The section, the level of section loss was so extensive. But, that's what we do. We go in and we were called in to kind of investigate these issues and figure out a way to get them addressed while keeping the facilities in service. And so our thought here is, what do we do? How do we fix this? And what's going to be the process? So what we ended up doing here is we decided we can't jackhammer. It's going to be too much noise. So we implemented going with Hydra Demolition. So in the Hydro process, is you're using high water pressure to cut the concrete. So you put high water pressure on, and all the bad concrete, you just push the pressure up close to whatever the compressive strength of the concrete is, and it takes up all the bad stuff. The bad part about that is when you're using all that water, and then because our garage is going 4 levels below grade, everything is running down, so how do you capture the water? And then because of the requirements by the city, we had a vacuum truck that's tied to the Hydra Demolition machine that sucks up the slurry, because the slurry, we just could not capture it in the deck and then put it into a landfill. It had to be sent to a specialized location because of the contamination. So what you're looking on the left is a vacuum truck that is actually sucking up all that slurry that's being produced by the Hydra Dem machine, and then that's taken to an off-site location where it can be safely disposed of. And here on the left, you can see that machine cutting, and then right behind it, it has the attachment of the hose to the truck that's actually sucking up as much of that disposed material as possible. But you can only capture so much. So what happens with the water? So now, because we're 4 levels below grade, so how do we get the waste and the water that's being produced? How do we dispose of that safely? So one thing that and it's typical for most hydro type repair approach, is you have to capture that water, and then you got to treat the water, the slurry that's being produced, you got to treat it, and then make sure, test it for the adequate pH levels. So what we did is we've constructed these containers in the lower level of the structure, at the lowest level on grade, because it's going to be a lot of weight. And then we captured all that slurry as much as possible in those containment tanks, and then the sediment settles, and then the water is not at the bottom, goes into the other tank, and then it's tested for the level of pH, and then it's pumped into the pump room down there, and then it's pumped up to the city main that we can adequately dispose of that. And these projects are very complicated because you have a lot of moving parts. The hotel, the core of the hotel, where the garage surrounded an active area for laundry and for all that stuff there. So we had to make paths for folks going in and out. We had to make paths for how they dispose of their garbage from the hotel. And on a few occasions, there were sprinkler pipes that were, knocked off because it's a sprinkled garage, and then the fire department shows up and you empty the hotel. And to be honest, we did it twice, and I think, just twice was good enough for us. But at the end of the day, it shows you the complexity and how we have to really go in, and it's not just about going in and demoing and fixing stuff. There's a lot of planning that's involved in making sure we can execute safely. And then, part of this, now you're looking at, you can see the extent of bad concrete that has been removed. You see these big holes in the floor. But and when we had shoring underneath, because the core, the entire slab itself is tied in as part of the core and is part of the entire structure. So we had to be very careful the limits of what we can remove at any given time in the garage, and how we make sure things are adequately braced and shored. And because the concrete is so bad, that once they shot blast, it just comes up. And so you can see on the left, so we have some small pieces of concrete that's left in place. Usually at the end, we just go and knock out all that bad stuff because it does us no good. And then on the right, we go back with forming the entire thing and embedding into the existing structure, and we go back with epoxy coated rebars. And again, even with the simple thinking of using epoxy coated rebar, we have to be careful, because when you cut those rebars, you got to make sure you treat the ends and stuff like that. So there's a lot of design. So we couldn't just throw back bars to match bars. We had to make sure we do some analysis in terms of figuring out how much reinforcement needs to be replaced versus how much reinforcement we've lost. So these repair programs can be very complicated, and a lot of times from the outside, folks don't really see that in terms of the engineering. The contractors, most of the contractors, they know because they've done this many times, what the expectations are when you get into these complicated projects. And at the end, this is what it looks like. It turned out to be a very successful project. created a safe environment. Before it was like, you would want to park there, but this is what we do. A lot of times, we get called in for scenarios where, it's hard to just get somebody to go in there and just willy-nilly and try to patch here and there. But at the end of the day, a big part of a lot of times is why we get to where we get to is a lot of times deferred maintenance, where enough money is not allocated by the asset owner or the whoever's managing the asset to address some of these issues before they get to this point, where you don't spend and address the issue, then it's going to be accumulative, and the scale is going to go pretty high. So so we've kind of showcased you, and again, this is just kind of our goal here is just going to give you a snippet of how we think about what we do and how we do what we do. We can spend hours and hours in talking through the nuances and the different types of what we do, but so hopefully this gives you an idea. So the next set of slides really are just some before and after, just highlighting segments of different parts of different projects. So these are different projects, different parts of just some before and afters, just to give you a flavor for how things move from being distressed or to a part where you address it. Here on the left, those two photos, the existing condition of the garage, and we were going to put a silane, a penetrating sealer, which is a sealer that penetrates top of the concrete to help with keeping water and moisture away from the reinforcement. So you can see the middle photos, that's where the shot blasting. You can see the difference with the cleaning, how nice it looks, and open up the pores so they can put a sealer on and then replace all the sealants, and it turned out to be real nice. So that's just kind of a sealer application there. Here we're looking at another structure. It looks like just a normal structure with a building, but there is actually a garage below. And Juan had talked about one of the structures that's overloaded, and this structure in particular got a bit overloaded with a lot of cracks developed. And in lieu of having routing and sealing all those cracks and creating larger cavities in the deck, we kind of convinced the owner put a coating on. And again, it goes back to the fact that we're saying there's means and methods and approaches that needs to be implemented. So just going in and routing and sealing thousands of linear feet of crack wasn't the best approach for the structure. So you can see how it looks now with an updated coating system in there. Here, again, we're just trying to highlight some of the uniqueness of how we think about some of these items when we address them. You can see in the middle photo there is a metal plate that separates two garage that we combined into one in terms of functionality. So they were independently functioned garage, and we functioned them as one, but that plate just kept on moving all over the place. So what we did, we reprofiled that, and on the right you can see we put in a nice wing seal expansion joint there that creates a nice transition to slow folks down, and also create a way that the water doesn't just sit and run through the joint there. So here, again, we talked about not everything is parking deck, even though here this plaza system is actually above a parking deck below. And here our goal was to try to help the owner with some issues with their pavers and the plaza system where it's just been shot, and they've gone through 3 other iterations of trying to address it. And so they called us in, and what we did, we said, hey, what there doesn't work, it sucks. Let's tear it up and go again. And so you can see the top 2 left photos is the existing condition, and the lower left is us removing everything and going back. And again, the devil is in the detail in terms of what we do, and how we do that in terms of, so here is just kind of a plaza system, a full system, built up system that we've put in. And at the end of the day, that's just kind of how it looks. And the client is still pretty happy, working fairly well.
Yeah, here we have more before and after examples. Again, we not just do parking structures here. We were tasked with cleaning and applying an acrylic sealer on the stucco throughout this building complex. You can see before picture on the left, and then the after picture on the right. Now I'm going to start showing you some before and after for structural repairs. Picture on the left, there's several levels of parking underneath that repair. The existing reinforcement was in bad shape. You could bend it with your hand. We have to kind of reverse engineer and figure out what was needed. Replace the reinforcement, and then the picture on the right, you can see the concrete repair once it was done. You can see on the picture on the right, Attila is hammer sounding the concrete repair to make sure that it was adequately done. And then here we have a PT beam that was inadequately designed, had a lot of distress cracks. We did an analysis on the beam, and then we epoxy injected the cracks. You can see all the ports where we injected the epoxy, and then we strengthened the beam with the carbon fiber wrap and carbon fiber plates. On the picture on the right, it's hard to see the carbon fiber because it was coated, but many layers of carbon fiber was used and carbon fiber plates. The picture on the right, you can barely see the repairs. We also have some expertise with bridges. Here we have a skyway or a bridge, and we were the carbon fiber engineer of record. We were tasked with strengthening the bridge, increase the shear capacity of the bridge. Here's a project where we did some PT repairs. Basically, the PT cables had a very shallow cover, so a lot of the PT cables were damaged. So we have to splice them. You can see the splice on the picture on the left, on the bottom, add a new piece of cable, and then on the top of that picture, we put a dog bone splice where we could retension the cables. Another thing that we did is we removed 1 inch of the existing slab to then put back 2.5 inches of macrosilica overlay to put the adequate cover that was lacking in the deck. So a big challenge just to remove that 1 inch of concrete. And then we also deal with a lot of steel structures. Picture on the left is before picture of a stair. The picture on the right, we completely replaced the stair. We put a stair that was code compliant. We also use a system that has a specialized material that makes it slip resistant. We can also repair stairs. In the picture on the left, the treads and riser were heavily corroded, so we decided to remove them, and we put a new tread and riser system with concrete. The picture on the right, you can barely see that any repairs were done. We also enclosed some of the stair tower with a new storefront to kind of keep some of that water out from the stairs. More structural repairs. The picture on the left is a PT beam that had, due to water getting into it, had a couple of cables that failed. We repaired the concrete, and then we supplemented the beam with a steel beam. Here the challenge was, if you can see the picture on the right, there's at least 40 holes that we had to drill through this PT beam. So we have to model the drape, scan the locations of the stirrup, so we can fabricate the beam. So we could fabricate the beam and miss all the existing reinforcement in the beam. Here's a retaining wall. The picture, well, it's not really a retaining wall, but picture on the left shows the wall was beginning to rotate. And so we were hired to stop the rotation. So we designed helical anchors to stop the wall from moving. The picture on the right, you can see some of the plates. Some of these anchors were 30 feet long, several rows to keep the wall from rotating. And here, the picture on the left, this is the exit. It's a double helix for a parking deck. The top of the helix was in bad shape, so we decided to install a macrosilica overlay on top of the helix. Some of the challenges just to kind of form the helix and the locations of the tool joint. You can see the picture on the right, how the end product, how it turned out.
All right, so that's really what we really wanted to kind of showcase today about, how we go about and how we get involved in these parking structure projects, and how we go about, kind of thinking through our approach and how we help different stakeholders with developing these programs and what the outcomes are. Hopefully, you found some of the information useful to you, and at this point, we'll open it for questions. I think, Cole, you're checking for any questions.
Yes, all right. Here we are, gentlemen. Thank you for the presentation. Here's one from Scott Woodworth. What is the average lifespan of precast steel and CIP parking structures with and without a maintenance program?
What's the life expectancy of precast parking structure?
Precast steel and CIP.
That's, you know, I mean, it depends, right? You know, they tell you it depends. So you're probably looking at, you know, maybe 30 to 50 years. And again, it depends on, you know, how much you spend with, you know, a lot of these design, it's, you know, what are you adding? You know, what are you, you know, you can add so much in terms of, you know, additional elements to the concrete itself and treatment and that kind of stuff to buy you more. So it depends on if it's a plain Jane structure or you want to spend a little bit more money to help with the long-term durability. And that's kind of where a lot of times is, you know, owners and developers get in trouble, is like they want a plain Jane. And, you know, you tell them, hey, you need to allocate, you know, X amount per space for maintenance each year, you know, because you're going to buy a cheaper structure. And those structures where you have a lot of steel elements that are exposed to the elements. And again, it depends on where you are in the country. You know, if you're in an environment where the environment is much harsher, you may not want to consider that type of structure. So you know, there are several different factors that has to be considered when you're, but for the most part, you know, you're building these structures, you know, 30 to 50 year initial life expectancy, but then there are things that you can add to extend that life. But with anything else, if you design it for that and you don't follow through the maintenance, you know, that life is going to be short. Hopefully that helps.
All right, I have another one from John Siebold. A traditional jackhammer demolition costs X amount of money. How much does Hydra Demolition cost?
So it's not easy to compare. You know, I don't think they're apples to apples, you know, in terms of jackhammering versus Hydra Demolition, because the processes are a little bit different. Hydra Demolition, again, you know, each application are different, you know, because, you know, jackhammering, you know, depends on the amount of work you have. You know, it depends on, you know, what type of structure you're working in. So I don't think it's easy to say. Usually, right off the bat, usually the Hydra Demolition process is going to cost you more. It's going to produce a much cleaner, nicer finish, a nice, clean bond, because anything that's debonded, typically in jackhammering, we kind of square cut to limit the growth of the patches that we have, and we try to check that out. It's not easy to do that with Hydra Demolition. Usually when you get in Hydra Demolition, you're taking off a certain surface to a certain depth, and the hydro pressure will create the nice solid surface when you're finished, because that pressure is taking off anything that's bad. So it's you know, it's very difficult to say, you know, compare one price to the other. So there's application driven.
Yeah, just to add to Andrew, Hydro Demolition has a very specific purpose. Some of the flimsier parking structures is really hard to do demo with Hydro Demolition. You may end up damaging the structure.
Thank you for the answer, gentlemen. I have another one from Dustin Kuzi. From an owner's perspective, how often would you recommend having a professional inspection done?
Well, that's a dependent question as well. So it depends on where you are, depends on the type of structure, depends on the age of the structure. You know, like if you're in Minneapolis, well, you know, the code requires that you have to inspect your structure every year. And it depends on, you know, the type and the age of the structure. You know, a lot of times if it's newer structure, you know, it's built last year, you know, it doesn't hurt to have an engineer walk through and just do a normal walkthrough. But, you know, I think once you get, you know, 5 years in, you really want, because at that 5-year marker, a lot of your warranty stuff is kind of kicking the curve, you know, your sealants and your deck coating. So that's really a good marker to start looking at, all right, do I need to start really planning? But again, it depends on the type of structure that you have. It's like, if it's a cast in place PT, well, we don't expect much to be happening, at 5 year. Maybe what you're doing for a 1 year for a certain structure is what you're doing for in a 5-year program for a cast in place PT. And then it depends on how well your structure is performing. If your structure is kind of, in a moderate to poor condition, then maybe you have to every year, unless you develop, a nice solid program that's going to push you further out. So it depends on if you're, how much work you're doing, how much effort, and where that buys you in terms of down the road. But, typically the newer structures, maybe after 5 years, you want to get an engineer in there, maybe every year, every other year. Depends on how well your structure is performing. But if it's an older structure, the investment is kind of a no-brainer. And again, when I say that, all these structures, we typically recommend that a dollar cost per space be allocated to maintenance, to be put in a pocket of money for routine maintenance for your structure. So at the end of the day, a lot of folks say, hey, I ain't got no money to do any investigation. Well, unfortunately, you didn't follow the plan. Or if there's a savings, because a lot of times what we start off with designing a cast in place structure, and the CM comes on board, and the first thing he says, I want to change it to precast. I'm going to save you $2 or $3 million. And the owner says, oh yeah, $3 million, we're going to go precast. And then we say, well, you need to save some of that money for, fixing some of the issues, because now you have a different type of structure that's going to behave different, and you have a lot of moving parts and sealant and stuff like that, and they take that money and invest it somewhere else. And then further on along the line, we have a lot of broken shear connectors to deal with. I ain't got money to fix it. So, it's kind of a big bundle response, but nothing outside of, what we would recommend in terms of approaching to an engineering assessment. And to that point, make sure you have the right individuals that understand what they're looking at doing the review for the structure.
Thank you, Andrew. I have another question from Chester McNulty. What would you recommend for educational material and educational opportunities for somebody who's in-house doing the day-to-day inspections on garages to better qualify him or her to know what to look for?
Yeah, so that's a good, a big question. I think there's a lot of courses out there that they can do, but a lot of times what we do, and which is not utilized, a lot of times when we design new parking structures, we develop a maintenance manual. And even when we do engineering assessment, some clients will say, hey, give me a maintenance manual. And those maintenance manuals are so useful, but they go on a shelf and they get dust. And those maintenance manuals, they have the previous repair programs, they have the materials that we use, they have typical details, they have conversation about how long, you should wash down the garage, what are the indicators of certain types. So these maintenance manuals has a lot of useful information that it's quite easy for them to sit with their staff and say, hey, let's talk through that. And then, if you can't find enough training, ask a professional. Hey, can you spend a lunch and learn with us to say, hey, tell us how we should think about, yearly wash down, what we should look for. And that's part of the goal here when we showed some of those distress. You see that stuff happening in your garage, it's time to call in a professional. And that's why it's important when you do like wash down of your deck, because you see the deck is leaking, you see water all over the place, you see these different type of stuff, something is wrong. So it's routine maintenance is very important, because it tells you a lot of stuff. You sweep down or wash down the deck, but it's hard to pinpoint a place to go. But where I would start is call your professional and ask them. And a lot of these professionals, they'll do a free lunch and learn to just kind of help you. It's not everything we want to charge for, to help you figure out how you should think about your structure and what you should look for. Hopefully you've seen some of that today, some of the stuff that, you want to know, hey, I need to call a professional.
We'll go ahead and do one more question. And if any attendees have any more further questions, we have Juan and Andrew's emails on the screen. I'm sure they'd be happy to answer those for you personally if you want to shoot an email to them. We'll go ahead here. James Anderson asked, what is the recommended annual maintenance amount of money a cure-all an operator or owner should set aside per space for future maintenance?
Tell James he should give them some of his money. James got a lot of money. Yeah, I'm glad, I know James was gonna ask something, so, I didn't expect anything different. He's a guru in this business, so.
Mhm.
So again, it depends on how far along. It's hard to pinpoint, where that number is usually between maybe $100 to $200 per space in your garage yearly that you need to really set aside, whether you're going to use it or not. So usually it's a kind of a per space. And again, it depends on the type of structure. If you have a precast structure that, is not a field top garage, well, you probably need to allocate more, but, you're probably, $150 to $200 per space as kind of a budget if you want to put together a budget. Seems like, but the bigger your garage, the bigger the cost of maintaining it. It's a smaller garage, then, but not, that's kind of a number. And again, it depends. It depends on where you are in the process. If it's a new structure or if it's a structure further down the line. If it's a structure down the line with a lot of need for repair, then, it's going to be a whole different ball game. It's hard to, at that point, it's hard to calculate, until you put a program in place to put a marker to say, all right, we've given you a new, slate, a new breathing room. From this point forward, start programming this amount of dollars per space for repair in the future.
Thank you so much, gentlemen, and thank you to everybody for joining us today. I'd like to personally thank Andrew and Juan for presenting that very exciting presentation and sharing your expertise with everybody. I'd like to remind everyone to keep an eye out for attendance certificates that we'll be sending out to everybody, and be sure to register and join us for our next session, Placemaking During a Pandemic, on March 17th at 12:30 Eastern Time. Thank you very much, guys.
All right.
We'll go ahead and move it off here.
Thank you, guys.
All right.
Appreciate it.
Take care, everybody.
All right.